Hello, greetings from Dr. Sadiq Ali. In the last video, we have seen definition of subspace and definition of homomorphism of a vector space V. Now, what is the definition of subspace? Suppose U is a non-empty subset of vector space V, and if this U wish to become itself a vector space using the operations which are defined over V, then this U is called as subspace of V. So by definition, the condition for the subspace is you take any two elements from that subset U, you take any two scalars from the field, here field is F, and then it's a combination, that is alpha x plus beta y. This element must be again a member of U. If this condition satisfied, then we can say that this subset U is a subspace of vector space V. Since definition itself containing both necessary and sufficient conditions, that's why we can use this condition in both ways. What is actual meaning? That when you know U is a subspace of vector space V, then by considering any two elements from the U, this quantity is again a member of U. This is the one way. And the another way is, if you have only subset, not subspace, you have only subset of V, and if you want to check whether that subset will be a subspace or not, then again you have to check this condition, and if this condition will be true for all elements of U like X and Y, then you can say that U is a subspace of U. Now suppose U1 and U2 are subspaces of vector space V over the field F, and I want to check whether the intersection of these two subspaces will be again a subspace of V or not. What is your conclusion? Now I am considering the intersection of these two subspaces, and I want to check whether this intersection will be a subspace of V or not. This is the question. Now, to become a subspace of any vector space, first condition is that quantity must be a subset of V. So since U1 and U2 both are subspaces of vector space V, it means that they are already subsets, right? And we know that intersection of two subsets is again a subset, and therefore we can easily prove that, or we can easily say that U1 intersection U2 is a subset of V. So here clearly U1 and intersection U2 is a subset of V. This is the first condition we have stated. Now, to check whether it is a subspace or not, you take any two elements from a set who wish to become a subspace. So let X and Y be two elements from this intersection. And again you have to consider two scalars from the field. So alpha, beta be the members of field F. Now, what will be your claim? Claim is to show that U1 intersection U2 is a subspace of E. This is a primary claim which we want to show. That is to show that alpha x plus beta y belongs to this intersection, and this is true for all xy belongs to U1 intersection U2. So this is the mathematical terminology. If we will prove this, we can say that U1 intersection U2 will be a subspace of E. Now how we will prove this? So here we have considered two elements x and y from U1 intersection U2, and by using the definition of intersection of two sets, because intersection is nothing but a collection of common elements which are belonging to U1 as well as U2. So here x and y both are the members of U1 intersection U2. It means that x and y both are members of U1 and both x and y are members of U2. So this we have written because of the definition of intersection. Now, if we look at this expression where x, y belongs to U1, now tell me, who is U1? U1 is already a subspace of V. So I already explained that when any subset is already subspace, then this will be happen for any two elements of that subset. So here U1 is a subspace, we know it, and therefore the alpha x plus beta y must be in U1. You can give the reason that U1 is a subspace already, and also U2 is also subspace. So according to definition of subspace, alpha x plus beta y is again a member of U2. So this quantity, which is same, now it is reflecting that alpha x plus beta y is a member of U1 as well as a member of U2. It means that that element is common in both U1 and U2. And hence we can write like this: alpha x plus beta y belongs to U1 as well as U2, that means intersection U2. And we have taken any two elements from the U1 intersection U2 whose names are x and y. X and y are just notations. The meaning, the important meaning is you have to take any two elements, and if this is true for any two elements, then we can say that this is a subspace, and therefore we can write this is true for all x, y belongs to U1 intersection U2, and all alpha beta, any two alpha beta belongs to F. And hence we can say that hence U1 intersection U2 is a subspace of V. So nicely we have proved this result. But the important thing is, here we have considered two subspaces, U1 and U2, and we have used or we have operated one operation on these two subspaces, that is intersection. And just we have proved that intersection of two subspaces is again a subspace. So instead of intersection of two subspaces, if I consider addition of two subspaces, then what will be happen? So now I am considering, see, U1 and U2 are subspaces of vector space V over the field F. Then if we add these subspaces, so is it again a subspace of V? That is the question. Now primarily at the inception we are thinking how we can add these two subspaces, because subspace is a collection with two binary operations, and since it is a collection, it containing elements, so how we can add these subspaces? So first of all, I will write how to define the addition of two subspaces. So suppose U1 plus U2, if I will add like this, you take any one element from the first subspace, that is X, plus you may take any one element from the second subspace, that is denoted by Y, such that X belongs to U1 and the Y belongs to second subspace, that is U2. So this is the actual construction of U1 plus U2. And we have to check whether this addition will be a subspace of V or not. So how we can prove this? So suppose if I consider one element and another element, second element Q, from this U1 plus U2. So this P, since it is a member of U1 plus U2, and as per the definition of addition, every element of U1 plus U2 can be written as sum of two components. First component is coming from U1 and second component, that is Y, is coming from another second subspace, that is U2. So therefore, if this P is a member of U1 plus U2, then definitely this P can be written as some element from the U1, it is denoted by X1, plus some element from the U2, that is denoted by Y1. And we must mention that for some X1 belongs to U1 and Y1 belongs to U2. Similarly, Q can be written as some element from U1 denoted by X2 and another element from U2 denoted by Y2. We can write for some X2 belongs to U1 as well as some Y2 belongs to U2. Okay. So if you look at this, this is X1 and this is coming from U1, right? And U1 is a subspace, and therefore this X1, which is a member of U1, and U1 is a subspace of V, therefore X1 is automatically be a member of V. Similarly, Y1 is a member of U2 and U2 is a subspace of V, therefore Y1 is also member of V. So in this summation, X1 and Y1 both are elements of V. And who is V? V is a vector space. It must satisfy all the 9 conditions of vector space. And the very first condition is the closure property. And according to closure property in vector space V, both this addition of X1 and Y1 will be a member of again V. So since this addition is a member of V and it is equivalent to P, therefore P is a member of V. Similarly, Q is a member of V. It means that any two elements or any one element, if you are considering from u1 plus u2, that element must be again a member of V. And if this type of things happen, then we can say that all the elements of u1 plus u2 are members of V, and therefore this u1 plus u2 is a subset of V. I wish just recall that the definition of subset. Any set A is said to be subset of another set B if all the elements of A are members of B. So we have logically proved that all the elements of u1 plus u2 are members of V, therefore u1 plus u2 is a subset, not subspace, subset of V. Now the claim is, what is our claim now? Now our claim is to show that this u1 plus u2 is a subspace of V. Now tell me, what is the condition required to check for the subspace? That is, you have to consider any two elements from this addition. Already we have considered P and Q. Now you consider any two scalars, alpha, beta. So if you want to show that it is a subspace, that is to show that alpha into P plus beta into Q is again a member of u1 plus u2. This actually we want to show. Then if we will show this, u1 plus u2 will become a subspace of V. Now, what is the characterization of u1 plus u2? The characterization is any element from the set u1 plus u2 is looking like sum of two members. First member is coming from u1 and second member must have come from u2. So if I want to show that this addition is a member of u1 plus u2, that means I have to set up this addition in such a fashion so that clearly I can say that the first part of the summation is a member of u1 and second part of that summation will be a member of u2. So now how I can write this? It's just so simple. So now I'm considering this element alpha p plus beta q. All right. The alpha is a scalar keeping as it is. What is the value of p? Tell me. What is the p? Okay, it is x1 plus y1. I'm putting this value of p instead of p here. Beta into value of q is x2 plus y2. Okay. Now, using the scalar multiplication rule, I can write this as alpha x1 plus alpha y1 plus beta x2 plus beta y2. Now, this term, first term and third term, I will take in one bracket. Alpha x1 plus beta x2 in first bracket, and the remaining two terms I will put in the second bracket. That is alpha y1 plus beta y2. Why I am doing like this? Because purposely I want to write this expression in such a way so that there should be a sum of two terms, and the first term will be a member of u1 and second term will be a member of u2. Now our first term is alpha x1 plus beta x2, and already we have declared that x1 and x2 both are members of u1. And who is u1? u1 is a subspace, and therefore the condition of subspace must be valid in U1. And this is the condition of linearity. Alpha x1 plus beta x2 must be a member of U1 because U1 is a subspace. And this, if you look at this, this is also a member of U2 because U2 is also a subspace. So you may write like that, since U1 is a subspace, this implies that alpha x1 plus beta x2 is a member of U1. Similarly, U2 is a subspace of vector space V, and this implies that alpha y1 plus beta y2 is a member of U2. So, if you look at this equation, that is, the first bracket is a member of U1 and second bracket is a member of U2, and therefore this is a element of U1 plus U2, and this is equivalent to this. Therefore, alpha p plus beta q is a member of U1 plus U2, and this is true for all p and q as well as all alpha beta, which are the scalars. So here we have shown sum of two subspaces is again a subspace.